Hi, I'm Matt, and in this video we are going to go over the ideal gas law. So, what is the ideal gas law? The ideal gas law allows us to determine the amount of moles of gas in a sample based off the pressure, volume, and temperature. This differs from the combined gas law because that only allowed us to compare two samples of gas that had an equal amount of moles, but we can never find out how many moles there were. This equation will allow us to do that. It's important to note that real gases don't perfectly mirror ideal gases, so this law will only provide an approximation for any calculated quantity. And the more ideal the gas, the better this approximation will be, but it will never quite be perfect. There are more advanced formulas to better include real gases, but we're not going to discuss those here. So mathematically, we are going to write that the ideal gas law is PV equals nRT, where P is the pressure measured in atmosphere, kilopascals, torr, or millimeters of mercury. V is the volume measured in liters. N is the amount of gas measured in moles. R will be our gas constant, we'll come back to that. And T for our temperature must be measured in Kelvin, not Celsius. So now, our gas constant, R, has different values based on the units it contains, and it must match all the other units. So, if we have our pressure in atmospheres, we're going to use that R is equal to 0.08206 liters atmospheres moles to the negative first, Kelvin to the negative first. Now, we'll only use that if our pressure is in atmospheres. If it's in torr, for example, we use a different constant, where it's 62.36 liters torr moles to the negative first, Kelvin to the negative first. There are more forms of this constant, but for this video, we're only going to use these two. Now, let's try some examples with this equation. So for our first example, we are told that a 7.50 liter sample of gas at 450 Kelvin has a pressure of 0.900 atmospheres. How many moles of gas are there in this sample? So the first thing we're going to do is write our givens. We're told that our pressure is 0.900 atmospheres. We are told that our volume is 7.5 liters. And we are told that our temperature is 450 Kelvin. No conversions are necessary because the temperature is already in Kelvin. Now, although we're not told, we know another value. We know the value of R because it's a constant. And since our pressure is in atmospheres, we're going to use that R is equal to 0.08206 liters atmospheres mole to the negative first, Kelvin to the negative first. Next, we're going to write our equation. PV equals nRT. And we're going to plug in the 0.900. Generally, you would want to plug in units with these numbers, but to save time, I'm going to omit them for now. Our volume is 7.50, and that equals N, what we're looking for, multiplied by 0.08206, multiplied by 450. Doing the math on the left, 0.9 times 7.5 is 6.75, and that's equal to 36.927 N. I got that by multiplying R and the temperature. And now to get N by itself and get our final answer, we have to divide by 36.927. And that will give us that the amount of moles is approximately equal to 0.183. And that will be our final answer. For our next example, there are 2.6 moles of gas in a 5-liter container at an unknown temperature. If the pressure is 1,280 torr, what is the temperature? So as per usual, we're going to write our givens first. We're told that our pressure is 1,280 torr. We're told that our volume is 5.0 liters. And our amount of substance, or N, is equal to 2.6 mole. We're solving for our temperature, but we're still missing something. We need our gas constant, R. And since our pressure is in torr, we're going to use that R is equal to 62.36 torr liters moles to the negative first, Kelvin to the negative first. And now we could write our ideal gas law. PV equals nRT, and we're going to plug in what we were given. So we have 1,280 times 5 equals 2.6 multiplied by 62.36 times the temperature. Doing the math on the left gives us 6,400 equals 162.136 times the temperature. And then our last step to get temperature by itself is to divide both sides by 162.136. And that gives us that our temperature is equal to 39 Kelvin. And we're going to leave it as two significant figures because that's as precise as our least precise value. For our final example, we are told that at 62 degrees Celsius, 5 moles of gas create a pressure of 15 atmospheres in a container of unknown volume. What is that volume? So we're going to write our givens first. We're told that our pressure is equal to 15 atmospheres. We're told that our volume is what we're solving for. And then we're told that our amount of substance, N, is equal to 5.00 mole, and that our temperature is 62 degrees Celsius. But remember, we have to use our temperature in Kelvin. So we're going to use Kelvin equals Celsius plus 273 to get the temperature in Kelvin. So we plug in the 62 for C and add it to 273, which gives us that our Kelvin temperature equals 335. And then we have to choose the correct number for R, which, since our pressure is in atmospheres, is 0.08206 liters atmospheres, moles to the negative first, Kelvin to the negative first. And now, after all that, we could write our equation. PV equals nRT, and plug in what we're given. So we have 15 times V, or our volume, is equal to 5 multiplied by 0.08206 multiplied by 335. And that gives us 15V is equal to 137.4505. And our final step to get our volume is to divide by 15. And that gives us that our volume is equal to 9.2 liters. And we're going to leave it at two significant figures. So that is our final answer. Now that we've gone through some examples together, here are 3 practice questions that you could try on your own. 2 hints I'll give you is, check that your temperature has the correct unit, and make sure you're using the correct version of R. Now at this time, I encourage you to pause the video, and the answers will be on the next slide for you. The solutions are as follows. For question 1, there was 0.406 moles of gas. For question 2, the pressure was 195 torr. And for question 3, the volume was 6.9 liters. Hopefully you got these. If not, feel free to leave any questions you have in the comments below, and I will get back to you as quickly as possible. Thank you so much for watching. Have a great day.